So for truth tables, how many rows and columns will our truth table have if we have a circuit with 3 inputs and 2 outputs? Well, let's take a look at this. So here's an example of such a circuit. We've got an AND gate with 2 inputs, so A and B gives us E, and then we've got an OR gate, which is going to OR the output of this, or E and C, to give us D. So we've got 1, 2, 3 inputs and 1 output here. Now, in a truth table, the truth table has to go through and show all possible combinations of inputs. So we've got 3 inputs, and they're binary. They can be 1 or 0. So all possible combinations can be 2 to the third or 8. So we're going to have 8 input combinations, so 8 rows of different input combinations. And then for how many columns we have, well, we have 2 outputs, so we're going to have 1 column for each output, and we have the 3 inputs, which we're going to do all the combinations of here. So we're going to have a table that's going to look like this. 1 column for each of the 3 inputs, 1 column for each of the 2 outputs, and then there are 8 possible combinations of 3 binary inputs, so we have 8 rows there. Now, let's go ahead and practice filling in the truth table. So here's a 4-input AND gate and a truth table, so go ahead and fill it in. Well, here's what it looks like, and it's not surprising. It's an AND gate, so its output is only true when all of the inputs are true. The rest of the time the output is always 0. And what you see here is all possible combinations of these inputs. So this is just binary counting up, 0, 1, 2, 3, 4, counting through all possible combinations and giving all the outputs for all those combinations of the inputs. Here's another truth table. So this is the circuit that has 3 inputs, A, B, and C, and an intermediate value E and an output D. So what's the truth table for this circuit? Now note this E here, this is sort of an intermediate value. It's not an output of the circuit directly. Well, here's the truth table. So we have all possible values of our combinations here. We have the outputs of E and the outputs of the results here. So let's take a look at how this works. So E itself here is A and B. So here's the case where A and B are true, and in those cases we see that E is both true. D is made up of 2 things. It's either when E is true, that is A and B. So here's when A and B is true, and in that case D is true. Or if C input is true, because remember this is an OR here. So C is true in all of these cases, and so in those cases the output will also be true. Now let's try doing it the other way around. How can you come up with the logic function from this truth table? Well, if we take a look at this, we can look at the places where output Q is true. So here Q is true, and our inputs A is 0 and B is 1. So that means that the equation for this is that Q is true if not A and B are true. Similarly, Q is true down here. In this case, both A and B are true, so this is going to be A and B. So now we can write out the equation for Q. So Q is going to be not A and B, the first one up here, or A and B, the second one down here. Now that's a rather ugly equation. If we were to simplify this, we just get Q equals B. And to see that, take a look at the truth table the other way around. Whenever B is true, Q is true, and whenever B is false, Q is false. So Q equals B.